In this video, we are going to talk about scientific notation. Now, scientific notation is a method of conveniently expressing really big numbers or really small numbers. So the first thing you're going to want to do is locate the decimal point. If there is no written decimal point, then you can write one at the end of the number. The next thing you're going to want to do is find the first non-zero digit, and this is when you are reading from left to right. After you've done that, you want to move the decimal point just to the right of the first non-zero digit, and you're trying to make a number between 1 and 10. And then finally, you're going to rewrite the number with the new decimal position. And the number of places you moved the decimal point will be the exponent in your scientific notation. If you have a number that is larger than 10, then you're going to move the decimal point to the left. And your exponent will be positive. If you have numbers that are smaller than 1, your really small numbers, then you're going to move the decimal point to the right. And your exponent is negative. So let's look at some examples. Let's first look at an example of a really big number. So let's look at 314 with 8 zeros. Now, the first thing I want to do is locate my decimal point. This is a great example of a number that doesn't have a written decimal point, so I'm just going to write one at the end of the number. Now I want to move the decimal point to the right of the first non-zero digit. Remember, it's always reading from left to right. So my first non-zero digit is my 3. So I want to move the decimal point to the right of that 3. And I can count how many times I have to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I'm going to rewrite my number, which then my new number with the moved decimal point is going to be 3.14. Notice 3.14 is a number between 1 and 10. And then I'm going to write times 10 to the, I moved my decimal point 10 places. This is a positive, or this is a very large number. So I'm going to make it a positive exponent. So I'll write it as 3.14 times 10 to the 10. The first part of this, the 3.414, this is the number portion of the scientific notation. And then the times 10 to the exponent, this shows the magnitude of the number. And the magnitude is just simply how big or small the number is. So I cannot quickly tell you what this number is. It's too many zeros. I'd have to move the decimal points. I cannot really give you anything except for I know it's a really big number. However, I can quickly identify how big and the magnitude of the number when it's written in scientific notation. Let's look at another example, this time of a small number. So we will do 0 point and then write 7 zeros, 1, 2, 3, 4, 5, 6, 7. And the number will be 729. So I'm going to follow the exact same steps. I'm going to locate my decimal point. This one is written, so it's easier to find. And then I need to locate, reading from left to right, my first non-zero digit. In this case, it is 7, so I'm going to move the decimal point to the right of the 7, or in between the 7 and the 2. For a small number, we're going to move the decimal point to the right. 1, 2, 3, 4, 5, 6, 7, 8. So now I will rewrite my number portion, 7.29. Again, this is a number between 1 and 10. And then I can show the magnitude of the number using scientific notation. So it'll be 7.29 times 10. I moved my decimal point 8 places, and this is a small number, so it's going to be 7.29 times 10 to the negative 8. Here are some good examples of different numbers that should be written in scientific notation. So looking at the distance to the moon or the sun. For the moon, I'm going to locate my decimal. It's not written, so I'm going to write it in there. My first non-zero digit reading from left to right is 3. So I'm going to move my decimal point to the right of the 3. 1, 2, 3, 4, 5. So when I rewrite this in scientific notation, it will be 3.8 times 10 to the 5. Now I can do the same thing with the distance to the sun. I'm going to write my decimal point in there, find where I need to move it. 1, 2, 3, 4, 5, 6, 7, 8. So the distance to the sun is 1.5 times 10 to the 8 kilometers. If we look at the diameter of a neuron, it is really small. I have my decimal point already written. I'm going to move it to just after the 5. 1, 2, 3, 4, 5. It is going to be 5 times 10 to the 5, but since this is a really small number, we need our exponent to be negative. So it is going to be 5 times 10 to the negative 5 meters. If we look at the diameter of a plutonium ion, I'm going to locate my decimal, find where I want to move my decimal, and then see how many places I have to move it. 1, 2, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 3 times 10 to the negative 10 because we have a really, really small number. Now we can look at the number of water molecules in a single drop of water. That is a lot. Oh my goodness. This is going to be a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh my goodness. So this is going to be 1 times 10 to the 21 water molecules. Hopefully you can see that if you don't do these little loop-de-loops, all those zeros can really, really, really start to run together. On this slide, you can go ahead and get more practice with taking a number and writing it into scientific notation. We also need to be able to take our numbers and put them into standard numbers. So if we have a number in scientific notation, we want to be able to write them in standard numbers. So the first thing you're going to do is write the number portion of the scientific notation. You want to include the decimal point, but do not include the times 10 to the exponent. You don't want to include that part because we're going to have to move the decimal. If you have a positive exponent, you're going to move the decimal point to the right. And you're going to move it a number of spaces indicated by the exponent. Essentially, what you want to do is just make a big number. Sometimes it's hard to necessarily see, oh, which way do I want to move my decimal point? If my exponent is positive or my exponent is negative, just if you have a positive exponent, make a big number. If you have a negative exponent, then you're gonna want to do the same thing as with a positive exponent, but instead we're gonna move the decimal point to the left and move the decimal point the number of spaces indicated by the exponent. And for this one, essentially, you're just going to make a really small number. So let's look at some examples. In this first example, I'm going to rewrite my number as 3.6. Now I know I have to move my decimal point 5 places, and I'm going to move it to the left in order to make a really small number. So 1, 2, 3, 4, 5. Now I'm going to do my third step, which is rewrite the number using standard notation and add zeros to show the magnitude of the number. So how big or how small the number is. So that means every time I do that little loop-de-loop, I need to add a zero. And I can rewrite this as 0.1234336. I see that I had 4 zeros. With a big number, I'm going to rewrite my number. So it will be 8.75. And I'm going to move my decimal point to the right to make a large number. I'm going to add the zeros in and then rewrite my number. You can go ahead and do the remaining two to get your practice. I would say one of the hardest things about scientific notation is learning how to use your calculator. So when you put this into your calculator, you want to look for your exponent button. And this is going to be your scientific notation button. On most calculators, it will be a capital EE. It might be written as an EXP, but this button means times 10. So you should never put times 10 in your calculator. So for a lot of your calculators, when you put 7.2 times 10 to the 3 into your calculator, you would put it as 7.2, press that E button, and then enter the number 3. Notice how we don't put 10 and we don't press the times button. And then you can press the times button because we want to multiply these two numbers together. And then you'll put 8.2 E times 10 to the 2. And when you put that into your calculator, you should get 5904000. Nope, just 3 zeros. Another way of writing this is 5.904 times 10 to the 6. It's very important that you get practice with using your calculator so you don't make mistakes on your exam because you don't know how to use your calculator. Your calculator is going to do exactly what you ask it to do, so make sure you're asking it to do what you actually want it to do. So the answer for this second one is 0.0000144 or 1.44 times 10 to the negative 5. The third one is 1,000,000,000, which should be 1 times 10 to the 8. And then finally, for our last one, we get 0.0000354, which is equal to 3.54 times 10 to the negative 5.